Alright, guys. Hi, how are you doing? So it's me again. Welcome to the third episode of my series about drawing fundamentals. Last week we talked about how to freehand ellipses and circles. So, so you have to draw from the shoulder. You the line before you actually execute it. So like that. Or to draw a circle, you also do a similar thing where you freehand stuff. So you will freehand. Uh, you will first on top of the paper, and then when you feel that you can make a perfect circle, that's when you start pressing down the pencil to create this circle. So here, uh, wait, let me shut off a few apps because it's so laggy right now. Okay. So 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 some of you might start wondering why do we have to learn how to draw freehand circles and ellipses? Uh, and what would be the connection between these two shapes? Uh, so so that's what the lesson today will be about. Let me erase this one. Let's move it over here. So the reason that we have to learn to draw both a perfect circle and an ellipse is because of the fact that these two shapes are actually one shape. If you so they're actually one shape in perspective. Uh, what do I mean by that? So what I mean is this. So so let's say you see a perfect circle. Actually, I will. So if you see a perfect circle like this from the front, right? So let's say that this circle is straight on the front of us, like you are looking right at it. You are looking right at it like that at the center. This will be a perfect circle. So this circle will be fitted right inside this square box like that. And all of these axes are even. So one by one, right? But what happens? So so let's take this round cap as an example. So this is the view that we are seeing on my drawing. So you will see this cap being perfectly circular, right? But what happened if you are not looking straight on, but instead this cap is being tilted like this towards you. So this face is no longer a circle, right? I mean it still is, but you see how it kind of got compressed and it doesn't look like an even circle anymore. So in other words, this face has become an ellipse. So I'll show you on here to make it clearer. So what happened to the cap that I showed you is this. So So we have a horizon line or eye line. This is a little bit of perspective. Uh, and then this cap has become like that. Actually, it has become like this. So you see how in this square there is this kind of connection. So same thing for that. So now we are not thinking 2D anymore. This is kind of like in a 3D space, like that. So our perfect circle over here has been compressed into an ellipse like that. So now you can start seeing how useful it is to be able to freehand ellipses because so because that way you can draw the ellipses in 3D spaces, right? Like you can draw circles in 3D spaces. Uh so both of these they are circles, right? But because our point of view or our perspective is different in terms of the way we look at them. This one we look at them straight on, but this one we look at them a little bit higher above, right? So so then the way they turn out on the paper looks different, even though they are still circles. Does that make sense? Uh, so now I'm gonna explain more about how specifically they how they specifically change. So if you would take a look at this ellipse on the left hand side, right? Do you see actually wait. So hmm, sorry, I'm just thinking about how I should explain this in the most easy to understand way. So so if you notice, what would be the main difference between this one and this one? So difference. So the main difference is that do you notice how these two lines still remain the same, right? So they are about, so it almost doesn't change. The biggest change, the biggest change comes from the way on the circle, this axis is equal to this axis, right? But on this ellipse, this axis is a lot shorter compared to the green axis of it. So it has to do with the characteristic of how an ellipse works. So on this diagram over here, so diagram, so an ellipse includes two of the most important axes within it. So we have the center and this blue line is called the major axis. So what is the major axis? Major axis. So what is it? The major axis. So if you think of the word major, major means big, right? So the major axis means the largest distance within an ellipse. So what I mean by that is that on this ellipse, there are infinite amount of points, right? So then, so then in between these 2 points, there is a distance, right? So we can have a point over here, a point over here, and then the axis will be over here. Uh, there would be one distance, right? And then over here and over here is another 2 point, right? So the distance between them will be like that. So what I mean by major axis is that I have picked 2 points that have the furthest distance apart from each other. Uh, so I picked 2 points on the circumference of the ellipse that have the largest distance away from each other. Yeah. So these 2 points that cross by the center has the largest distance. If you don't believe me, you can try it out. You can just pick any 2 point on the circumference of the ellipse, and then you use the ruler to measure the gap between them, like that. You can use a ruler to measure this gap, and then I guarantee you this gap will always be smaller than this major axis line. So that's what it means. So I will write down largest, sorry, my computer is lagging. Largest distance between 2 points. Actually, let's cross this one. My wording is not that great yet. Distance between two. Oh, sorry, guys. I'm not working my best today. So, distance between two furthest point apart of the ellipsis circumference. So that's what major axis is. So since we know what major axis is, can you guys guess what minor axis is now? So so this green line will be your minor axis. Oh, actually, I was wrong. Um, so actually, this blue line, this will be the blue line, and this will be the green line. So so only the green line is changing in terms of length, but the blue line is still the same. And that green line that is changing is what we would call minor axis. So minor axis is the shortest this is the distance between two closest, see the keyword furthest and closest, so closest point apart on the ellipsis circumference. Okay. Again, if you pick any point, any 2 point on the ellipse, and then you measure the distance between them, I guarantee you that distance will be larger than this minor axis. Because, like I said, minor axis is the distance between 2 points that are the closest apart on the circumference of this ellipse. So basically, any distance, any 2 points that you pick on the circumference, the distance between them will always be larger than the minor axis, and it will always be smaller than the major axis. And remember, they always have to pass through the center. So pass through center. Same thing for here. Pass through center. Okay. So again, I will repeat it. So when you look at these two, you will see that the major axis, which is the blue line, doesn't change their length when you put it in a different perspective, right? So when things turn away, when this circle turns away, the major axis still stay the same. Only this minor axis gets smaller, right? So this one, the ratio the ratio of major and minor axis over here is still 1 to 1, right? But the ratio between the minor and major axis has become more about 1.5 to 2, right? This has become shorter. So basically, you need to worry about minor axis, worry about this one, okay? Because that because when a circle turns away from you in perspective, only the minor axis will change in terms of length. The major axis remain constant. So I'll show you more examples of how it works in perspective. Oh, so let's expand this one. Okay. So now, so let's say once again, we have the horizon line. So we have an open space like this, right? Oh, sorry, it's lagging. So like that. So in the center, we have a perfect circle. I like to confine my circle inside a perfect square like this. like that. So let's say I want to rotate this square like this, like this on the side. Like I want to rotate it a little bit to the side like that. So let's draw an arrow. What would it be like? So again, from this VP, this will be still be the same circle, but this time mm, so the square has turned to the side, right? And then the circle that is confined within it has become an ellipse. So if you notice, this will be the major axis. This is the major axis. And then this is the minor. And this has become the minor axis. And this minor axis has become smaller, right? So the same thing is that, okay. So here is something else that is so important with the ellipse. So I will show you how it works first and then I'll explain it later. So let's say I want an ellipse that is somewhere in here, right? I will draw my ellipse like this. So I am ghosting it, and then when I feel it right, I will draw, I will execute my ellipse right here. Okay, so around here, the ellipse looks very thin, right? But if you are going to draw your ellipse down here, like down here, then you cannot draw this exact same ellipse anymore. You have to draw it wider. It has to be wider. You see this gap? It has to be wider. Same thing down here as well. You cannot, this ellipse has to be even wider. so that in order for it to feel right in space, you see how believable that is? Uh, let's see a wrong version of it. So this is the wrong version. That, that, that. Okay. You see how it doesn't make any sense. So within the space like that, we have gone from smaller to bigger, right? And when I mean smaller to bigger is in terms of this gap over here. And do you know what gap this thing is called? It is called the minor axis over here. So so the same idea will apply even if you go above the horizon line, right? So this is on the ground. But let's say if these are flying UFO on the sky, you see how that makes sense now? So let's say these are like clouds and then they have the base as the ellipses. You see how we can feel like this is closer. Actually, let me try again. You see how this feels closer, and then this is further apart towards this one. It gets smaller and smaller, right? Not just in terms of their size, but the way the ellipse is compressed, like this width gets smaller and smaller and smaller, right? And smaller, like that. So basically, what I mean to say was that the closer to the closer the closer the ellipse to the horizon line, the smaller the minor axis, which lead to flatter, flatter ellipse, and vice versa. the further to the horizon line, bigger the minor axis. What I mean by bigger the doesn't mean it will get so big that this ellipse become like that, right? So let's say this cloud is over here. Let's say this minor axis become bigger and bigger. It will never get so big that the cloud become like that, right? No. So the bigger the minor axis until it is 1 to 1 with actually never mind. What I meant is that the further away to the horizon line, the minor axis will get bigger and bigger, but the maximum length that the minor axis can reach is only the length of the major axis. So the widest, the widest that this cloud can go. So the widest this minor axis can go is the same as the major axis, which means you will have a cloud that is a perfect circle like that. You will never have this thing, okay? It will only get to this in terms of the ratio between the major and minor axis. So equal major axis max. And that means we will have a rounder ellipses, and eventually we will have a circle if it gets further enough. Does that make sense? I hope that makes sense. uh, so with that, we can move on to a higher level. So cylinders. Mm, I feel I would have moved on to cylinders, but I feel like this is a little bit too loaded already. So I think I will stop the video here, and then next week, on the next episode, I will review the ellipses first, and then show you guys how to apply it to draw the cylinders. Okay? I hope this lesson makes sense. Again, if you still have any question, feel free to reach out to me, and then we can have a Zoom meeting, and then I can personally explain it to you, whatever point that you did not understand. Thank you so much for watching. Please share and subscribe if you found this video helpful. I would really appreciate it. And that's all. Have a good one.